Namaste dosto. Imagine you have a triangle, but you don't know its height. Maybe it's slanting or irregular, and measuring the altitude seems tricky. Pause. That's exactly where Heron's formula comes to the rescue. This clever formula lets us find the area of any triangle just by knowing the lengths of its three sides. A, B, and C. No need to measure height or draw extra lines. Now, here's a little history to spice things up. Heron, or hero of Alexandria, was an ancient mathematician who first came up with this formula. Quite amazing, right? But remember, the sides A, B, and C must satisfy a certain rule called the triangle inequality. That is, the sum of any two sides must be greater than the third side. In other words, A plus B is greater than C, B plus C is greater than A, and C plus A is greater than B. Without these conditions, a proper triangle doesn't form, and Heron's formula won't apply. So next time you face a tricky triangle, just check these inequalities and you can use Heron's powerful method to find the area easily. Shabash. Now, let's see why Heron's formula is so handy. Sometimes, the traditional method of calculating a triangle's area, using base times height divided by 2, just won't work. Imagine a scalene triangle with all sides different and no obvious way to measure the altitude or perpendicular height. How do we proceed? Here, side-based methods like Heron's formula become super efficient. For example, surveyors and engineers often deal with irregular land plots or structures where measuring height isn't practical. By knowing just the three side lengths, Heron's formula simplifies the work and avoids complicated constructions. Remember, the three sides contain all the geometric information needed, as long as they are consistent with the triangle's rules. This makes Heron's formula a powerful tool in real-life applications where precision and simplicity matter. Excellent beta. Before we jump to the formula itself, there's one important step: calculating the semi-perimeter of the triangle. The semi-perimeter, denoted by S, is simply half the sum of the three sides. So, S equals the sum of A plus B plus C, all divided by 2. This semi-perimeter acts like a helpful baseline for the area formula. Using S makes the expression much simpler, especially when height isn't known. Since for a fixed triangle the sides, and therefore S, are constant, it helps us apply the formula straightforwardly without extra fuss. Think of it like preparing ingredients before cooking. Once S is ready, the rest of the formula falls into place easily and neatly. Areva, isn't math fun when broken down like this? Alright, the moment we've been waiting for, the statement of Heron's formula. Suppose we have a triangle with sides A, B, and C, and we've already found the semi-perimeter S, which equals A plus B plus C divided by 2. Now, the area of the triangle is given by the square root of the product S times S minus A times S minus B times S minus C. Let me say that slowly once again. Area equals square root of S multiplied by S minus A, multiplied by S minus B, multiplied by S minus C. Keep in mind, the expression inside the square root must be 0 or positive to represent a real, valid area. And of course, this formula works only when the triangle inequality holds true. So this nicely combines everything we discussed: side lengths, semi-perimeter, and the magic of the square root to get the area. Shabash, you're doing great following along. Picture a triangle drawn on the board, with sides labeled A, B, and C. This triangle isn't necessarily right-angled or equilateral. It can be any kind of triangle, scalene, isosceles, or what you like, as long as it's valid. The labels A, B, and C can be rearranged for clarity, but always make sure that the triangle isn't degenerate, meaning the sides must satisfy those triangle inequalities we talked about. This diagram helps us visualize how Heron's formula depends only on the sides. No angels needed. By focusing just on A, B, and C, we understand the area in a new way, through the lengths alone. Just remember, your input sides must create a real triangle to apply Heron's formula correctly. Excellent job keeping up. Let's wrap up everything we've learned so far. First, Calculate the semi-perimeter S using the formula S equals A plus B plus C divided by 2. Next, use Heron's formula for the area, which equals the square root of S times S minus A times S minus B times S minus C. Key points to remember. This formula works perfectly when only the 3 side lengths are known, and we don't need to find height or angles. It cleverly avoids extra constructions by a derived square root expression from the semi-perimeter. Also, always confirm that the triangle sides follow the triangle inequalities, or the formula won't hold. Soch ke dekho. With just side lengths and a little arithmetic, we find areas quickly and accurately. Great going. Keep practicing this, as Heron's formula beautifully links geometry and algebra in one neat package. Arey wah!